All right, who's first? Keep that question for me somewhere. Tell me where it is, what it is. Let's go.
On question 3 in the review, I got a different slope. I just wanted you to go through how you got that.
What slope did you get?
I think I got like 4,375. I don't know what I did wrong, because it's like kind of
Okay, so we'll figure that out, but first of all, look at this question. Can the slope be a positive number?
No, it's not. Yeah. I think I got negative 4,000.
Oh, okay.
But still, it was wrong.
All right, so what do I got? I got a couple of ordered pairs. In the beginning, it was 137.5. After 8 years, it was 102. And so your slope should be 102,000 minus 137.5 over minus 0.
Yeah.
So is mine right or wrong?
Right.
Okay, well, I'm gonna type it in. Right? Okay. So you figured out what was wrong with your slope?
Yeah, I just had the 135 from accident. Like I had those two slips on.
Gotta go the same order, right? So you're gonna do 8 minus 0, you gotta do this minus this, right? Could go the other way, but then you have to have 0 minus 8. Okay, then you can get the equation of your line and answer your question. All right, who else has something from either homework or review sheet?
On 13, it's like that was. Are we allowed to do an
It says solve algebraically. I mean, if you want to do matrix operations by hand, you can, but you can't just type it in.
Oh, that's what I mean. I can do it by.
Yep, yep, because really, the matrix operations are elimination. In fact, those processes are called Gaussian elimination. So, yeah, yep. As long as you're doing it with algebra and not with the technology, yep, yep.
Can I see number 5?
Huh?
Can I see number 5?
5? Okay. Remember, I'm old, you have to talk loud. All right, what's happening here? We got a line segment out there. This is, so here's line AB. And we want to write the equation of the perpendicular bisector. So, isn't that a line? What do we need to write the equation of a line? We need the slope. Now, I don't know the pink slope. But can I find the black slope? And then what will I know about the pink slope? Opposite reciprocal. So my black slope, 6 minus 4, negative 2 minus 8. I'm getting negative 1/5. Keep an eye on that arithmetic. Is that okay? Now that's the black slope, which means the pink slope is 5. Now, what else do I need if I'm going to write the equation of a line? I need the slope and I need a point, some point. I have no idea about any points on that line except this one. What does bisect mean? Cut in half. So that is the midpoint. And how do I find the midpoint? Add them and divide by 2, average them. So negative 2 plus 8, that would be 3. And 6 and 4, that would be 5. So I'm going to write the equation of the line with a slope of 5 containing the point 3, 5. That would be the point slope form. If we wanted the, I probably did points on there, but I wouldn't. But if I wanted the slope intercept form, it would be that. Okay, all right, who else? 7. I know. idea. Karen, what are you thinking?
To find the distance between the midpoint.
Well, you can definitely find that distance, but remember, that's gonna be a radical. Like, I don't know, the square root of 83, okay? How is that number gonna help you find that point? It isn't, because you know that distance is the square root of 83, I'm making that up. But so is this distance, and so is this distance. So the radical isn't gonna identify a point. So what might be a different idea to use? What is that? That's the midpoint. What do we know about the midpoint? It's the average. So I don't know what this is, but the average of it and -8 is 1/5, right? So x minus 8 over 2 equals 1/5. I'll cross multiply, but you can do whatever you want here. So it looks like that's gonna be 42/5. And then I can do the same thing. 4 plus y divided by 2 is -7. The average of 4 and y has to be -7. So it looks like that one is -18. Okay, now that's one way to do that problem. So the problem literally says midpoint. So you could certainly think about, okay, I'll do midpoint. Okay, that's what I did. Another way to think about it is, and it's a little bit trickier with the fraction, but in going from -8, which is -40/5, and going from -40/5 to +1/5, how far did I move? Going from -40 to +1. 41. So I went 41/5. So I am gonna go 41/5 more, which puts me here. And then from 4 to -7 is back 11. So I'll go back another 11 and I'll be at -18. So that's another way to think about it. It's more intuitive. All right, who else?
Can you do 5 on the homework?
Which homework?
P8.
Are you just now doing your homework?
Well, yeah, but I just don't know. I like looked at it. I wouldn't know how to do it.
I totally frown on doing homework in class, so yeah. But since you assure me that you have spent time outside of class pondering the problem,
Of course.
that's my skeptical look. All right, the dimensions of the field, perimeter's 220. Now, if the perimeter's 220, then half the perimeter, one width and one length, would be 110. Does that make sense? So if this is x, that would have to be 110 minus x, because these two have to add up to 110. So the area is 3,000. So x times 110 minus x is 3,000. So negative x squared plus 110x minus 3,000 equals 0. This is going to be a quadratic equation. I don't like that negative, so I'm going to get rid of it. I'm allowed to do that because it's set equal to 0, so I can divide everything by -1. And now I have to solve it. So, I mean, I'm sitting here looking at my answer key, so it's popping into my head that this factors. But if you didn't see that it factored, then that would be understandable because those are big numbers. then what could you do to solve that equation? Quadratic formula, yeah. And so this one happens after. So what are the dimensions of the field? 50 by 60. Now, I didn't do it with the system. You could have, if you would have called one dimension x and one dimension y, then you could come up with two equations. xy equals, what was our area? 3,000. And 2x plus y, or 2x plus 2y equals 220. And you could do the problem that way too. This is your area, this is your perimeter, and you can do substitution or elimination, and you'll come up with an equation that looks just like this.
For 9A on the review, would square root of 16, would that be an actual number if it equals 4?
Absolutely.
It would be.
Square root of 16 is 4, right? And 4 is an actual number. Yep.
This isn't a specific question, but when there's like an inequality and there's like kind of two sides and there's like two inequalities, when do you like make it into two separate inequalities to solve? This is like yes, there's you kind of just like are able to solve it without making it into two. Like
You mean
when,
8F on the review sheet?
yeah, 8F.
Yeah, because there's only one X and it's right in the middle.
So if there's two X's,
If you cannot get X, you can't move things around and get one X, then you're gonna split it up. Now, you can always split it up. You can always do that, but you have to do it if you can't get X by itself in the middle.
Is the process of checking the signs, like when we're doing the distance formula, does that work
Wait,
on
wait,
every?
wait, wait. When we're doing the distance formula,
Or not the distance formula, the like number line,
Yeah,
the,
yeah.
does that work for every single
every
problem?
single problem,
Okay.
every single problem. On, what am I-
the review.
the review, number 4. Okay, we need to know our basic projectile motion formula, which is what? This is H, yeah, sometimes it's S. H of T equals negative 16T squared plus, well, V sub naught T plus H sub naught, right? And from the problem, we know that the initial velocity is 100 and the initial height is 24. So here is my equation for this particular problem. This is the generic. This is this particular problem. Now, I want the height above the ground to be at least 50. Okay, so I've got a couple of options. What could I do? We have to do something. Put 50 in here. And then solve that equation. Now, I can certainly solve it by hand, getting an exact answer. How would I solve that by hand? Hopefully, I keep an eye on my arithmetic, make sure I subtract right. So, how would I solve that by hand? Use the quadratic formula, right? So T equals obviously I need help with that. No way can do that. So I got, under the radical, I got 8336. Anybody do this by hand? Does that look familiar? Oh, let's see. So that's two answers, isn't it? So negative 100 plus the square root of 8.36 equals divided by negative 32. So one of the answers is 0.27 seconds. When is the ball 50 feet above the ground? 0.27 seconds. And another one. 5 point, you see, I rounded in there thousands, that's what I should be doing. So 272 and 5.978. So those are the two times when the ball is exactly 50 feet above the ground. Now, that wasn't the question, though. The question was, when is it more than at least 50 feet above the ground? So, you should know, I mean, in a minute we're gonna graph it, but without using your calculator to graph, you should know what shape this is. What's a t² negative? Opens down. It's a parabola opening down. So this is gonna look like this. Remember, it started up here on top of the building. So this is 24, and then up here is 50. And here are the two places where it's exactly 50. If I want it to be 50 or more, then that would be the interval from 0.272 to 5.978, right? That's when it's at least 50. Now, I could have done that, gotten those same answers on my calculator by graphing exactly what I graphed here. Graph my parabola, graph 50, and figure out where they cross. Okay? I'm gonna answer the second part. I did that algebraically. I'm gonna do the second part with my calculator. It says, when will the object hit the ground? So now I'm looking for that point, right? Right there? So I can do that on my calculator. If I'm doing it by hand, go back to my equation right here. This was my equation for the problem. If I want to solve that by hand, then what am I going to do? Plug in 0 right here. So I am going to solve this equation using the quadratic formula, right? If I do it by hand, I'm going to do it on my calculator because we haven't done one yet on the calculator. So I got a bunch of stuff in here from other days, so I'm going to get rid of that stuff. And this is what I'm typing in right here. So negative 16 x squared and luckily I had my windows set for a different problem, but it came out, I see a nice little picture. So you're gonna wanna play around with it till you see that. You wanna see something that looks like that. And then I wanna find that point, so I will second calc 0, not intersect. I'm looking for a 0. And I need a cursor set here and a cursor set here. Looks like that point is, when does it hit the ground? 6.481 seconds. Anybody else get that? Now, if you do it by hand, if you solve this with the quadratic formula, how many answers are you automatically going to get? 2, right? But one of them is going to be negative. And so you'll throw it out. It'll be extraneous. We didn't worry about it on the calculator because that wasn't an option. But, okay? All right, what else? Some of your homework wasn't very good, folks. I hope you got it figured out.
Can you do number 1 on P5?
Five. Okay. So this is from the P5 homework. So we've got. We know the area of the whole thing is 200, and they tell us this is X. So they kind of define every area for us. X is that. Alright, so what shapes do we have here? We have a square and a semicircle. And that has to add up to 200. So what's the area of our square? X squared. Semicircle will be 1/2 pi r squared. So what's the radius of my semicircle? What's that guy right there? 1/2 x. So my semicircle is 1/2 pi times 1/2 x squared. And that has to equal 200. So x squared plus, okay. So 1/2, 1/4, that's 1/8 pi x squared. This is 1/4, there's a square in it. So 1/8 pi x squared has to equal 200. Right? Now, this one is actually a little easier than it could have been because we can actually factor out an x squared. And then we can divide by this parentheses. So x squared equals that, yes. And then our answer will just be the square root of that. Right? So let's type that in. 200 divided by parentheses 1 plus 1/8 pi. And then square root of that. I got x equal to 11.983984 inches. By the width of the window. That would be x. Now, when I said this is a little easier, keep in mind that if this had not been an x squared, if this had been a plain x, then you would have subtracted 200 and done the quadratic formula, and that would have been b, and you just would have had to deal with it, right? But we got lucky. We didn't need to do that. We could just factor. Okay? All right, what else?
I have a question on B on the review. Like, I got the answers, I just don't know how I write it.
D.
Or 8D.
8D. I have the answer and I don't know how to write it. Well, let's see. what did you do first, Warren?
Well, I put that into my calculator.
Okay, let's do it algebraically. There are, you can definitely, I mean, yeah, I have to kind of limit this calculator use because some of our problems are no calculator. This would be a no calculator problem, okay? So how would we do this if we couldn't use our calculator?
Move the X to the other side.
Move the X to the other side. Guys, when you are solving things, I'm not gonna say every single time, but the huge majority of the time, you wanna have it set equal to 0, right? So, moving. Now what can you do? Take an X out, we start factoring. Right? That is X minus 1, X plus 1. So here's my trusty number line. And the zeros or the dots on the number line are going to be where? 0, 1, and negative 1. And now part of that number line is going to be shaded, and I gotta figure out what parts are shaded. So I can pick a number somewhere, I'll pick one out here like 2. If I put 2 in for all my x's, won't I be positive, positive, positive? Is that what I want? Yep, so we're gonna shade that. Now I know, and you know, what's gonna happen now. Since I shaded that one, I won't, I will, and I won't. If I'm expected to show my work, then I'm gonna do the same thing here that I did here, right? I'm gonna pick a number like 1/2, and then negative 1/2, and negative 2, right? So we're all okay with that process, right? If we have to do it, we can do it. All right, so how do I write my answer? Well, it's the interval of numbers from negative 1 to 0, or it's the interval of numbers from 1 to infinity. When you graph that on your calculator, here is your cube, and here is your, not very good picture, here is your x. That's what it should look like when you graphed it. And you want the cube, which is the squiggle, to be above the line. So that would be this part of the graph and this part of the graph. That's where the squiggle is above. Now, the calculator will tell you this point has an x value of -1. Obviously, this is 0. And that's what, those are your points of intersection. So where is squiggle higher than line? Between -1 and 0, and after 1, which is exactly what we got.
Can you do the like distance thing for 8B?
8B. First thing I would do is divide by 4. I don't want to have a 4 or anything in there, so I'm going to divide everything by 4. So here's my number line, and right in the middle of the number line, those 3/4. If that had been x plus 3/4, that would be a negative, because it's a difference. I'm gonna have a dot out here and a dot out here. They're gonna be solid because of that. And I'm gonna go this way 5/4. So 3/4 plus 5/4 puts me at 2. And then I'm gonna go back 5/4. So that's gonna put me at -1/2. I want the distance, this is the distance exactly 5/4. I want it to be more than that. So it's gonna have to be out here or out here. So no matter how you do the problem, this is the answer you have to come up with. exactly like somebody who already did one. This is like the one, Ada didn't have the slope right or something. It's exactly the same problem. So what are my two ordered pairs? At the beginning, no years past, 42,000. 8 years past, it's now 67.5. So there are my two ordered pairs. This is for, how did you know to look for two ordered pairs? Well, anytime it says something about linear, I think about a line. And what do I need for a line? I need to know the slope, the rate of change. So on my slope, I'm sure that's something. I got 3187.5. Basically, what is that slope representing? What is that telling me? Every year, my price goes up that much money. That's what's happening. Every year, I go up that much. So, first part says, write the equation. Well, that's my slope. What's my y-intercept? 42,000. So there's my equation. And then when I want to know when it's worth 80,250, I'll just put 80,250 in right here and solve it for T. Okay, yep.
On P2, number 5 was write the equation of the circle, or of the circle.
Aiden, what does the equation of a circle look like? Just in general.
I think it's x minus x1 squared plus y minus y1 squared equals radius squared.
Yep, that's exactly what it looks like. Good. That's what a circle looks like. So what do I need to know? What goes here?
Just,
The center. I gotta have a center. So what do I have in this problem? I have a center at 3, 2. Okay, so x minus 3, y minus 2. That's done. They told me what the center was. So here's the center. And then the circle contains the point -1, 4. That means it's on the circle. So how am I gonna find my radius? Just gonna be the distance, right? So the radius is gonna be this one over there, 2 minus -1 squared plus 2 minus 4 squared. So that's 16 root 20. So what goes up here? 20 r squared.
Can you do number 2 on 6?
P6. If complex numbers are equal to each other, then their real parts are equal and their imaginary parts are equal. So I went ahead and distributed that negative over there. Alright, so with my red marker, I'm going to circle everything on this side that doesn't have an eye. So what doesn't have an eye over here? Right here, right? What doesn't have an eye over here? Right right there. So negative 5x has to equal negative 17, so x equals 17 fifths. If you don't have an I on the left and you don't have an I on the right, set equal to each other. Now these two have I's, and this has an I. So 4i minus 2i is just 2i. So 2 has to equal 2y, so y must be 1. You have an I on the left, you're equal to things with I's on the left. There's a P6 on one. Alright. All good. Alright, and I told you after we're done reviewing, we're gonna get started on something, so that's what we're going to do as soon as I can find it. We'll get started. Alright, so I need you then to put all that stuff away, and we're gonna get out our BFF sheet. We handed out a long time ago. It looks like this. Basic family of functions. We're not gonna take long on this, we're gonna like dwell on this and make it hugely complicated, but it's important going in, we learned this the hard way last year, it's important going in that you have knowledge of some of these basic functions. So, here's what I want you to think about. We're not necessarily gonna fill in every single thing, that would take us forever, and we're not gonna do it. But you do need to know what the equation looks like, what the picture looks like. All right? And what the domain and range are. Okay? So let's focus on that. And we'll talk about those other words, because those are all calculus words. Those are words we're definitely going to talk about, especially like asymptotes and behavior. But we need to, first of all, what does the identity function look like? What shape is it? It is our linear function. It is the line that goes right through the origin at a 45-degree angle, quadrants 1 and 3. What are the points on that line? If x is 1, y is 1. If x is 2, y is 2. Hence called the identity y equals x. Y equals x. What is its domain? How far left and right does this picture go? Forever. So negative infinity to infinity. No restrictions on the domain at all. If this is your equation, can you put in anything you want for x? Now, we're dealing with real numbers now. Okay, we're in real number land. So put the i's out of your mind. We're graphing these. But can't you put anything in? Could you put in a fraction? Could you put in a radical? Yeah, it doesn't matter. Anything can go in. How about range? Okay, it's gonna be the same, isn't it, guys? You said y is x. So whatever the domain is, that's what the range is. One of our favorite functions, no issues with it at all. let's go ahead, might as well, and talk about the end behavior. What we mean by end behavior is, what does the curve do as x goes that way and as x goes that way? And the way we write end behavior, LIM stands for limit, underneath it, x approaches infinity of our function. This is our function. And what happens as x approaches negative infinity. So when you write end behavior, this is the way you're going to write it. This says, what happens to my y's as x goes to the right? Well, let's look at the picture. As x goes to the right, here's positive infinity. As x goes to the right, what are my y's doing? Where are they going? Positive infinity. They're shooting up into space. What about as x goes left? Negative infinity. Okay? Now, these don't always match, guys. You got to look at your picture. But that says, that notation says, as you go to the right, you go up. As you go to the left, you go down. That's end behavior. All right, the squaring function. That equation would be y equals x squared. In parentheses there, write quadratic, because that is another vocabulary that you will hear probably more often than squaring. A quadratic function. And what is the shape of a quadratic? We already talked about it. It's a parabola. So, anytime you have an x squared equation, you are going to have some variation of that shape. That's what x squares look like. Every time you have an x equation, you're going to have some variation of this. What's the domain of the quadratic? Yep, everything. Everything. There's absolutely nothing you can't plug in and square. Be careful. What about the range of the quadratic, though? 0 to infinity. And that 0 is included, so it looks like this. That's your range. Very, very good. Now, let's talk about end behavior. Every time we do end behavior, you don't want to write it. There's no shortcut for it, but you're going to write the limit as x approaches infinity of your function is something, and the limit as x approaches negative infinity of your function is something. And this is the function we're looking at here. So tell me, what happens as I go right? Up, so that's positive infinity. What happens as I go left? Also up, positive. Cubing function, you know what he looks like? Anything with an x cubed? Yep, Spencer, that's right. I like to call it the squiggly. Now, they can be, when you start throwing other stuff in there, every cube is going to be a variation of this, but they can be much more curvy. So for example, you can have them look like this. They can also be upside down. But this is the basic curve. They're called the basic family of functions. These are the basic functions. Tell me about its domain. Negative, all real numbers. Yep. How about its range? Same. right, let's do the end behavior. Remember, every time we do end behavior, we're writing this. So, limit as x goes to the right. What is happening in my picture as I go to the right? Up. And left. There's 12 of these guys. I know. Look at the fun we're gonna have. All right, here we go. Now we've got the reciprocal function, which is the equation y equals 1 over x. Now, this one is our first, what we call discontinuous. When I graph a parabola, I can graph the whole thing without lifting my pencil. When I graph a cube, I can graph the whole thing without lifting my pencil. That's called continuous. There's like a definition for continuous. It's hard. The idea of continuous is it's not broken anywhere. This one is broken. This one has asymptotes at x equals 0 and at y equals 0. Now, I want you to think about that for a second. I think it's pretty obvious to you that x can't be 0, right? And in math land, cannot be's, if you cannot be something, you're an asymptote. Okay? So I have x cannot be 0, so I'm going to have an asymptote there. Now, can you tell that y also can't be 0? Think about that for a second. Will 1 divided by something ever equal 0? No. So x can't be 0 and y can't be 0. This is called a vertical asymptote. This is called a horizontal asymptote. Now, let's just plot a couple points real quick. If I put in 1, I get 1. Would you agree? If I put in 2, I get 1/2. But if I put in 1/2, I get 2. The shape I get is this. A little hyperbola. You guys do hyperbolas last year? It's a hyperbola. And that's what happens if x is positive. Guess what's going to happen if x is negative? I'm going to get exactly the same shape. It's definitely got symmetry, but it's down here in quadrant 3. Is that okay with everybody? All right, domain. Last one, let's get her done. Domain is what for this problem? Negative infinity to 0, and then 0 to infinity, because isn't your domain everything except 0? So we'll just skip it. And then our range, would you agree, is the same? Everything except 0. Now, end behavior. Remember, end behavior describes what happens as you go all the way to the right. Well, as I go all the way to the right, what is happening to my y values? They're approaching 0. And they're approaching 0 from the top. So I put a little plus sign up there. That tells me I'm approaching 0 is a horizontal line. So as I approach it, am I coming in from the top or the bottom? I am approaching 0 from the top. Now, what happens when I go to the left? I'm also approaching 0, but this time it's from the bottom. That little negative is not a negative. It is a from the bottom, from the negative side. Okay? Wow, good stuff. I'll pause there. And we'll pick up after, I guess we'll do that on Friday. I wasn't